So let's go ahead and get started. Solving equations. Okay, I have an equation here. I always like to draw my line down the middle. So go ahead and write this equation in your notebook, because especially with equations, the more you write it, the more you practice writing it down, the more you're going to memorize it, the easier it's going to get later on. So make sure you're always copying down what we're doing in class so that you have it in front of you and you can review it at home. All right, so I have this equation here. What should I do to solve it? What are some things I need to get rid of?
The parentheses.
Yeah, I have parentheses. I want them gone. How do I get them to go away?
Distribution.
Distribution. Beautiful. So that brings us to our very first property of equality. We're going to distribute. And I'm going to write these properties down on the right-hand side because those come back in the test you guys have on Monday. This should be a very easy question because those properties you should already have pretty memorized. But I'm just going to write them down today so that we just continue to remember what they're called. So distributive property, I have to multiply. 4 times 1 is 4. 4 times negative x.
Negative 4x.
Negative 4x. Negative 3 times x.
Negative 3x.
And negative 3 times positive 1.
Negative 1. I mean, negative 3.
Negative 3. Good job. All right, cool. Now I look at my equation, and do we see anything that we can clean up? Do I see anything that I can, what can I do?
3x. We need to get rid of the negative 3x.
Okay, so you guys want to go ahead and move this guy over already. That's fine, but there's something I can do first. Always think about how I can.
Oh, you can combine like terms.
Yeah, there you go. We can combine like terms.
So it will be 6x, right?
Mm-hmm. Oh, well, careful. Don't forget that this negative always belongs to the number that comes right after it. So even though technically this says 4 minus 4x, we think about it that as a negative 4x, because when you combine like terms, that's going to be negative 4 plus 2, which gives me
negative 2.
Negative 2, exactly. 2. So now I have 4 minus 2x equals negative 3x minus 3. And now we can move that 3x over to the left side. And what property should I use to move this negative 3?
Addition.
Good. How did you choose addition?
Because the 3 is a negative and we have to switch.
Good. We always use the opposite of the operation that you see in front of you. So since it's negative, the opposite is addition. So that's my addition property. Okay, now where do I add it? Where else do I put it?
Under the 2. Negative.
Good. Cool. All right. And now that I have to do a little bit of addition. So what's negative 2 plus 3x?
1.
1. That's it. 1. So I get 4 plus, and since I have 1x, do I need to write that 1 down?
No, because the x is already basically a 1.
Yeah. So it's not, and I want to make sure we understand this. It's not that x equals 1. It's that there's just one of them. There's just one x there in front of me. So I don't really need to write that 1 because that would just be saying the same thing. Okay. So I just write x, and then I get on the right side, don't forget this negative, I have negative 3. Oops, negative 3. Cool. Should be one last step. Now what do I do?
Get rid of the 4.
Got to get rid of that 4. How do I get rid of it?
Subtraction property.
Perfect, subtraction. So just don't forget that when you have a positive number, that positive number technically has like a little plus sign in front of it. So in order to get rid of it, we're going to subtract. And what's negative 3 minus 4?
Negative 7.
Negative 7. So x equals negative 7. Done. All right, so this was a four-step equation.
I
Questions?
got confused.
Which part?
At the ending, I was about to divide.
Yeah, sometimes, I mean, usually you would have to divide on the last step, but since the x was already alone, there was no reason to divide by anything. So maybe in the next problem we'll have to divide. Any other questions, comments, concerns? This one did not have any fractions, so it was a little bit easier. We love that when there's no fractions. But this is just a good review of everything that we've learned in this topic. So, of course, I got to do a fraction. And we're going to do quite a few. We're going to do about 2 more fraction problems. All right, so this one is a special type of fraction problem because there's just one big fraction on both sides, right? And does anyone remember what you need to do when you see this type of fraction problem?
Cross multiply.
Yeah, good, Juan. We're going to cross multiply.
Yes.
So that's my first step. And what does cross multiply mean? Can anyone explain it?
Multiply from both sides.
So I'm going to be multiplying something on both sides, but what do I multiply on the left side?
3.
Yeah,
And 4.
good. So this 3 gets multiplied to the left side. And what about on the right side?
-2.
The 2.
Yeah, that -2 gets multiplied to the right side, exactly. Now, what happens is the denominators will go away, and we're going to be left with 3 times n plus 4, and then -2 times -3n minus 5.
Miss,
So-
I don't understand.
So that's what I kind of want to explain how this works. Like, why does that happen? So here's why. I'm gonna take a step back. Give me a moment. And I just want you guys to watch what I'm doing. Cross multiplication skips a couple of steps. It's like a quick way of doing something that actually takes a little bit longer. Because what I'm actually doing is if I want to get rid of this 3, remember, fractions, any fraction in the world is really a division problem. Really what's happening here is -3n minus 5 divided by 3. And what's the opposite of division?
Multiplication.
Yeah, multiplication. So if I wanted to get rid of that 3, the opposite is to multiply. So what I would do is I would multiply by 3 on the right side, but since I'm multiplying by 3 on the right side, I also have to multiply by 3 on the left side. And what happens is that denominator cancels out. So now, okay, now I have 3 times n plus 4 over -2 equals -3n minus 5. So I only got rid of the right-hand side. Now I would do the same thing on the left-hand side. I have this -2. In order to get rid of it, I got to multiply by -2 on both sides. And what happens is it crosses out. And I'm left with 3 times n plus 4 equals, I have this -2. I'm going to multiply it to everything. So I'm going to put some parentheses in there. So what cross multiplication is those 2 steps combined into one. Instead of doing each step individually, cross multiplication kind of like kills 2 birds with 1 stone, okay? But do you guys understand why it works and why we end up with what we get?
Yes, because the cross multiplication is easier than doing like putting all the numbers together.
Yeah, it's like a shortcut, exactly. Okay, so as long as the most important thing to remember is that anytime you want to get rid of a fraction, what do you multiply by?
The denominator.
The denominator, exactly. Anytime you need to get rid of a fraction, we multiply by the denominator. Okay. So now that I've shown you the long way, I'm going to go back and rewrite it with the quick way, which is my cross multiplication. Okay, so this gives me what I got in the end. So 3 times n plus 4, and then -2 times -3n minus 5. Now that I'm here, what should I do next?
Distribute.
Good, now I can distribute. Okay, here we go. Distribution. What do I get on the left side?
3n plus 12.
3n plus 12. And then on the right side?
+6.
Positive 6n, good.
+10.
Plus 10,
Right.
good.
Plus 10.
Good. Remember that distribution is multiplication, right? So when I multiply -2 times -3, I get +6. And then -2 times -5 is +10. So that's why we ended up with positives. And now I'm really close. What should I move over?
The 6n.
6n. Good.
6n.
Good. What operation do I use?
Subtraction.
Subtraction.
Good. Minus 6n and minus 6n. This is subtraction property. Cool.
You get -3
I get
Mm.
-3n.
plus 12 plus 10 equals
Perfect.
10.
Equals 10. Yeah. Awesome. And now what needs to go away?
The 12.
The 12. Yeah. How do I move that 12 over?
Subtraction.
Subtract it.
Good. Minus 12, minus 12. What's 10 minus 12?
-2.
You have 2.
Good.
Okay, so this is an example.
I have a question in the chat. Who would like to answer this question? Ready? Why did I put in the previous step, the orange, when I put the -6n under the 3n? Why did I put it under the 3 and not under the 12?
Because they're not like terms.
They're not like terms. What do you always have to match up?
The
The variables, exactly.
Variables.
Good, good job, guys. So I put it under the 3n because both of these have an n, they match. If I put it under the 12, those would not match because the 12 doesn't have an n with it. So you always have to put it underneath the one that's a like term. All right, last step.
I forgot what to do here.
What do I
Add
do?
2. Add 2.
Well, I'm trying to get
No.
n all by itself.
I don't know if we should divide by -2 or divide by -3. That's what I'm confused about. Oh, by itself. Okay, so -3.
Good, there you go. So you're trying to get n all by itself. That's your goal. Your end goal is to get n all by itself. So the number that's in the way, the number that needs to go away is that -3.
3.
Yeah. So that's why we divide by -3.
You cannot.
Why am I dividing?
Because -3n is together by multiplication.
Perfect. Exactly. -3n, when I say -3n, I'm really saying -3 times n. And the opposite of multiplication is division. So when I divide, my final answer
Is 2 -3.
is n equals,
Oh yes, and -3.
you're close, positive. Yeah, because I have -2 divided by -3. Two negatives make
Oh, a positive.
a
Okay.
positive. So I end up with positive 2/3. All right, so this one was definitely a little more challenging, especially that first step with the cross multiplication. So what questions do you guys have for me? What questions do we have?
What if we're like dividing by a fraction in the first step?
In
It
the
is a fraction. Okay. Well,
yeah.
that's a very ignorant question.
No, yeah, you're on. So anytime you have a fraction in the very beginning, that's the first thing you want to get rid of. You want to have whole numbers because fractions, If you had to add or subtract fractions, it would just make your life a lot harder. So anytime that you have fractions, that's the first thing we want to get rid of, which is why we did cross multiplication. Cross multiplication eliminated all my fractions right away. Any other questions? Okay, do you have to turn it into a decimal? So remember what I've always said with decimals versus fractions. Look at the answer. This is going to be a multiple choice question usually, right? Look at the answer choices. If all your answer choices are fractions, then you know that you need a fraction. If all of your answer choices are decimals, then you're going to need to turn it into a decimal. But it always depends on like what the answer choices are, as well as what type of problem you have. Because sometimes it might be a real world problem and the question is like, how much does it cost? If it's asking you how much does it cost, are you going to keep it as a fraction or are you going to turn that into a decimal? If I'm talking about money.
This would be decimal since it's 2/3.
Yeah, it would definitely be turned into a decimal. So if this was a real world problem and it was talking about money, then my final answer would be 0.67. I would turn it into a decimal. Okay, so I think that answers that question. Any other questions? Okay, all right, let's do another one. Like I said, we have more fractions. So here's a kind of a more intense one. There's a lot of fractions, right? What else do we see that so we definitely have fractions. What else do we have?
Parentheses.
Parentheses.
Yes, parentheses.
So we definitely want to get rid of both of those things. Well, if you have fractions and parentheses, the first thing you probably want to do is, it really, you can go either way. You can either try to get rid of your fractions first or try to get rid of your parentheses first. In this case, let's try by getting rid of our parentheses first. Because last time we did fractions first, this time let's just do parentheses first. So parentheses, what's that property called again?
Distribution.
Distribution. So distributing. We're going to practice a little bit of fraction multiplication here. All right. So I need to multiply, right? I'm multiplying fractions times whole numbers and fractions times fractions. So let's practice this. First thing I'm doing is 2/3 times 1/4. How do I multiply fractions? Yeah.
No. Yeah.
Yeah, straight across. So 2 times 1 and then 3 times 4. So 2 times 1 is 2. 3 times 4
12.
is 12. And can I simplify that?
Yes.
Yeah, this would be 1/6. Don't forget that to simplify fractions, all you do is you try and divide the top and the bottom by the same number. So 2/12, if you divide both of those by 2, you get 1/6. So that's my answer that's my first term here. Oops. 1/6 x. Okay, now I need to do 2/3 times -2. Can I write -2 as a fraction?
Yes.
Yeah, what would I?
-2/1.
Yeah, -2/1. And then you just do the same thing, straight across. So 2 times -2 is
0.
multiplying, not adding.
4.
Yeah, -4
4.
over
3.
3. Can I simplify that?
No.
No, so I'm going to leave it. Okay. Now on the right side, I have to do 1/5, 1/5 times 4/3. Again, straight across, what do I get?
4.
4/15.
4
4 over 15. Good. Can I simplify that?
La siguiente va a
Yes.
ser polígono.
Yeah, you could divide by 4.
Con esta palabra,
Yeah, I can divide by 4?
Yeah.
What's 15 divided by 4?
la primera.
No.
No.
No. Yeah, you can't. There's no number that I can divide both of them by. Okay, so this would be, I would just leave it as 4 over 15x. And then finally, 1/5 times -1. Well, anything times 1 is just,
1/5.
yeah, we just leave it as 1/5. All right, that was our quick lesson on multiplying fractions. And I see a couple of questions in the chat, so let me just make sure that I am answering them. So, okay, one of the questions, could I leave this as 2 over 12? You could leave it, it wouldn't be wrong, but you always want to try and simplify your fractions as much as possible because it just makes the math easier. And you'll see why in the next step. So anytime that you notice you can simplify, do it. You always want to simplify as much as you can. How did I get -4 over 3? Okay, -4 over 3, we multiplied. So 2 times -2 was -4. And then 3 times 1 is 3. So that's how I got -4 over 3. And why did I do -2 over 1? Well, that's because in the original problem, I had to do 2/3 times -2. I had a whole number. But when you multiply a fraction times a whole number, it's easier to turn that whole number into a fraction so that you can multiply it straight across. So that's why we did that. All right, any other questions on all of that multiplication? Okay. All right, cool. Now, okay, I have all these fractions. I definitely want to get rid of them. I got rid of my parentheses, but I haven't gotten rid of my fractions yet. So, remember what we talked about in the previous problem. What do you usually want to multiply by in order to get rid of those fractions?
Denominator.
The denominator, right? But take a look, I have a bunch of different denominators. I have a 6, I have a 3, a 15, and a 5. And they're all different. So does anybody remember what you need to do when all of your denominators are different numbers?
Least common multiple.
We multiply.
Find the least common multiple.
By the, Juan, I can barely hear you. Can you get a little closer to your microphone?
Find the least common multiple.
The least common multiple. Okay. So we're going to multiply by the least common multiple, the LCM, of all of those fractions of 6, 3, 15, and 5. So here's what LCM, let's do a quick review of LCM. The least common multiple is if I list out, so let's list out the multiples of 6. 6 times 1 is 6, then I have 12, then I have 18, and I keep going, 24, 30, and so on. You want to find the first number that they all have in common. So some of you already know it. I see it in the chat already. If you already know what it is, then you can move on to the next step and start multiplying, okay? But let me go step by step for everybody else. So for 6, those are the multiples of 6. Then we've got the multiples of 3. We have 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, so on. What are the multiples of 15?
15, 30, 40.
15.
Yeah, 15, 30, 45. And we're already getting pretty high up, so I'm going to stop there. And then the multiples of 5. 5, 10.
5, 10, 15, 20, 25, 30.
Okay. So what is the lowest number that they all have in common?
30.
30, yeah. 6, that's got 30, 30, 30, and 30. All right, do you see that? So that is my LCM. The number 30 is my magic number. That's what I'm going to multiply all the way across this entire equation. And the reason for that is that when you multiply by 30, it's going to eliminate all of those fractions. Every single one is going to go away. All right, so let's do it. I'm multiplying everything by 30. So I'm going to break it down. Here we go. So I got 30 times 1 over 6x. And then I've got 30 times negative 4 over 3. $30 times 4 over 15. And if you already know how to do this, I know some of you guys like to go ahead and do it. But if you're sticking with me, stick with me. We're writing all of this down. Okay. And notice that I made sure to copy down all of the correct pluses and minuses. So anywhere there was a minus sign, I made sure to put that down. Anywhere there was a plus sign, I made sure to put that down. All right, here we go. 30 times 1 over 6. What do you get?
You could put the 30 underneath.
So I could have, I would do 30 over
1.
1, and then you multiply across, what do you get?
30
5.
over 6.
30 over 6, and then I can simplify. What's 30 divided by 6? I think Bianca said it. Can you say it again?
5.
5, yeah. So this is 5x. Then I have 30 times 4 over 3. Again, I can put 30 over 1. 30 times 4 is 120. 120 divided by 3, what does that give me?
40.
40. Okay. Once again, we can put the 30 over 1 and multiply across. So that would be 30 times 4 again, that's 120, and then 120 divided by 15.
8.
8. And then finally, 30 times 1 is 30, and 30 divided by 5
6. Negative
is
6.
6. Yeah, and I have a negative sign, so minus 6. So notice it was kind of, we had to take it step by step, but it was very worth it because now all of those fractions are long gone. We got rid of them. And from here, I want you guys to finish it out. So solve for x on your own. Should be 3 more steps. Go ahead and do it on your own and then give me your answer in the chat when you have it. All right, finish it up. I'm seeing some correct answers. All right. Let's go through it. So I'm going to just erase these LCMs so that I can write my next step. What would my next step be?
Subtraction.
Subtraction. What am I subtracting? Subtracting.
-8.
-8.
Good. -8x. And again, where am I writing it under and why?
The 5. Because they can be, because they are like terms.
Good. They are like terms. All right. 5 minus 8 is
-3.
-3. Okay. Next step. What do I do here?
Addition.
Addition.
What am I adding?
6.
6? Do I want to move the 6 over?
We're not adding the 6, we are adding the 40.
The 40. Good. Remember, you always want to think, what am I trying to get rid of in order to get x all alone? Who needs to go away? So the 40 got to go away because that x needs to be alone. So what's -6 plus 40?
30.
What was that one? Nice and loud.
34.
34. Good. Okay. And then in that final step, how do I get rid of that -3?
Divide.
Divide. Good. What am I dividing by?
-3.
Good. So I'm dividing by -3 on both sides. So I end up with x equals 34 over -3. Now, this is the type of question where you can look at your answer choices, and if all your answer choices are fractions, then you're good to go. But if your answer choices are decimals, did anybody get it as a decimal?
-11.3.
Yeah.
Oh, negative?
And then
was
the
negative.
mixed number form is -11 1/3.
And 1/3. Yeah, and mixed numbers, by the way, they kind of don't exist in algebra. In algebra, you're either going to have a improper fraction like this one or a decimal. Mixed numbers, they kind of, I don't really know why, but they don't really use them too much in algebra.
All right.
All right, so there you go. There's your answer. Kind of a weird one, you know, not sometimes you get nice whole numbers and it's beautiful, and then sometimes you get these ugly fractions, and that's okay. Don't get too freaked out if that's the case. Any questions? Good. A lot of you guys got it correct, so good job. Good job to you.
Question.
Mhm.
So do we leave it as a fraction, or it will be better as a decimal?
Again, it all depends on the answer choices. Each question is going to be different on the test. If, for example, if this was the calculator section of the test, then it's easy enough to turn that into a decimal by dividing on your calculator. So sometimes in the calculator section, you're going to see more decimals just because they know you have a calculator in front of you and they know that you can just do that math really quickly. Okay, so it really just depends. Read each question, and you're going to see on the homework assignment that I'm giving you guys, you'll see those answer choices, and the answer choices might be fractions or they might be decimals, and it just depends on the question. Okay. All right, so so now we're going to go ahead and do inequalities. And the good thing about inequalities is that they're pretty much exactly the same as equations. Does anyone remember the one little thing you always have to remember, though?
If you're multiplying by a negative number, then you have to switch it.
Yeah, and not just multiplying, but also
Dividing.
dividing. So if you multiply or divide by a negative, the symbol, the inequality symbol flips. So if you had a greater than or less than or equal to sign, it would flip to become a less than or equal to sign. So that's just something that we got to keep in mind. but everything else is going to be the same. So we're going to treat this just like a regular old equation. And I have fractions. I also have parentheses. What should I get rid of first? It doesn't matter, by the way. Either one works. So what do you guys want to get rid of first?
The parentheses.
Cool, let's get rid of those first. So what is the property called?
Distribution.
Distribution. Distributive property. Cool. So I'm going to distribute. On the left side, 2 times x is 2x. 2 times -4,
-8.
-8. Greater than or equal to 1/2 times x is just going to stay as
1
times x.
half x.
yeah, 1/2 x. And then what is 1/2 times -4?
2.
-2. Good. Again, you can do this the long way. 1/2 times -4 over 1. That's -4 over 2, which is -2. Or you can do it the quick way, which is remembering that 1/2 is the same as dividing by 2. So 4 divided by 2 is 2. All right, so I got rid of my fractions, or my parentheses. Now I get rid of my fraction. What do I do to get rid of it? I only have one fraction to worry about, so what do I do?
Multiply.
Good, I see Alyssa typed it in the chat. We're gonna multiply by 2 because we only have one fraction. We only have one denominator to worry about. That's easy. All we have to do is multiply by that number. But remember, we have to multiply by 2 all the way, everything. Everything gets multiplied by 2. All right, so let's go ahead and I'm not gonna write it all out. I'm just gonna do it kind of in my head, but what's 2 times 2? 2 times 2x?
4x.
4x. 2 times -8?
16x. 16, -16.
Good. 2 times 1/2 simplifies to what?
X.
Just x, yeah, because 2 times 1/2 is just 1, so I have 1x. And then 2 times -2 is -4. So I just went through, all I did was multiply by 2 all the way across that whole inequality. And now, down to my last 3 steps. Step 3, I'm going to kind of move quickly through this one because we're kind of getting the hang of it now. So I'm going to subtract. I'm going to subtract and move that x over.
3x.
Yeah, we get 3x minus 16 is greater than or equal to -4. Now I'm going to
Add 16.
good. I'm going to add 16. -4 plus 16. What's -4 plus 16? 12, good. And I'm going to pause here to answer a couple of questions. Question number 1, how did I get 3x? Who can tell me, how did I get 3x?
By subtraction, not subtraction, subtracting the x on to the left.
Yeah, so remember, x by itself is the same as 1x. So all we did there was 4 minus 1. That's how I got 3. And then why did I multiply by 2? Why did I do this?
We multiplied that to
Yeah. Good, Raymond. The denominator of 1/2 is 2. And the whole point is that we're trying to get rid of that fraction. So notice in that, once I multiplied everything by 2, that fraction went away. No more fractions. That's the reason we did it. All right. Last step. What do I do here?
Divide.
Divide. Divide by 3. And my final answer would be x is greater than or equal to 4. And notice I didn't have to flip my symbol. There was at no point did I divide or multiply by a negative number. So I didn't have to flip that symbol. That is my final answer. And very quickly, we're going to graph this. So remember, when you graph an inequality, you just have a number line. And that number line is going to have a couple of numbers. So I could put 0, 1, 2, 3, 4, 5, and 6. What type of circle should I put down and what number should I put it on? Good, it's going to be a closed circle according to Alyssa. And why is that going to be closed?
Because it's equal to as well.
Good, because my symbol, I have a greater than or equal to symbol. And when it's equal to, this is kind of like solid versus dashed line. Remember that? Solid line versus dotted line. When it's equal to, when it's greater than or equal to or less than or equal to, that's a solid line. And it's also a closed circle, just like this. And then I'm going to be shading to the right. To the right, because x is greater than or equal to 4. So since it's greater than or equal to 4, it's got to be to the right. So any questions on graphing this or on how I got my final answer? What questions do you guys have for me?
Can I say something?
Nice and loud, Juan, yeah.
If I forget if it's closer, not if it's closed circle or
Or open circle?
I like to think of it like what you call it, the if it's less than or equal to that symbol makes the circle, and then the line fills in the circle.
So you're saying like if it's less than or equal to, can you say that again, how you like to remember it?
Um, the less than or equal to sign makes the circle,
Mm-hmm.
and then if there's a line, it fills it in.
Oh, okay. So the line underneath kind of represents like the fact that you're filling it in.
Yes.
Yeah, that's a good, helpful way. Whatever way helps you to remember these things, any of those little tricks you guys have, those are really useful. And I always, like, if you have a good one that works for you, always share that with the class because it might help somebody else. So thank you, Juan. All right, let's do another one. But what I want you guys to do is to try this one on your own completely. There's no fractions here. So I want you guys to do this one on your own and see what you get in the end. I'm going to give you guys about 5 minutes to complete it as well as graph it on your own in your own notebook. All right, so 5 minutes begin now. If you're done, you can send me your answer. Okay, I still have about 2 minutes left, but I know a lot of you are done, so if you still want to finish, let me know in the chat. Otherwise, I'll just go ahead and move on. If you still need a little bit to finish up, just let me know. Okay, I'm going to take that as a no, and now we can go over it. Alrighty. So step 1, I have some parentheses. What should I do with them?
Distribution.
Distribution. Ijara, you're like the distribution queen. You always answer that question. All right, multiplying. 3 times 2 is 6, so I got 6x. 3 times -1 is -3. So 6x minus 3 less than or equal to 4x plus 7. Now, what do I do? Guillermo says math. Okay, what math?
We take away the 4x by subtracting.
Good, subtraction property. Minus 4x over here, minus 4x over there. Always line it up with whichever other number has an x with it. So 6 minus 4 is 2, so I've got 2x minus 3 is less than or equal to 7. Now what?
We add 3 to the 7.
Good, we're gonna add 3 on both sides. 7 plus 3 is 10. So I've got 2x is less than or equal to 10. And then finally,
Divide.
divide.
Wait, are we gonna have to like write down our steps in the mid-year?
You won't have to write them down, but there are some questions where it's going to show you, you'll see one like it tomorrow, but basically it'll show you, like, it'll say like, oh, Danny did these steps. Which of the steps is wrong? Or it'll be like, what step or like what property did Danny use in step 4 or something like that. So you have to know what they're called, but you won't have to actually write them down yourself. So x is less than or equal to 5. How do I graph this?
I messed up because I thought the
So the
7
area
was a negative.
Oh no, you brought down
I
a
got
negative number.
-4, and that's when I had.
And then you got
Hmm.
to -2 or something. All right, well, that was a silly mistake. Remember, silly mistakes, these types of problems are only difficult because of those silly mistakes. And they can be really frustrating sometimes, I know that. Because you're like, I did this whole problem almost perfectly, and then you just messed up like on one tiny little thing.
Wait, Miss, you said it was correct. I had the wrong answer.
What did you have?
I had two is less than x is
Oh
less
yeah.
than or equal to 2.
Oh, I'm sorry. Did you do that same
did.
thing? You subtracted 3 instead?
Yeah.
Okay, so I'm sorry. I was answering everybody at the same time and I must have misread your answer. Silly mistakes, they really do get you. Open circle or closed circle?
Close.
Closed circle. Pointing to the
Right.
Left.
left or to the right?
Left.
Left. Left.
Left, yeah. X is less than or equal to 5, so left.
Well, we should know that because the sign, like the arrow, is pointing to the left.
Yeah, and that's a little trick you can also use. This symbol is pointing to the right, so my arrow also points to the right. And over here, this symbol points to the left. The little tip of it is to the left, so my arrow can also go to the left. That's a good little trick to remember. Okie doke, so now we have like 2 more problems on this, but now we've got compound inequalities. Compound inequalities are almost exactly the same, it's just that you got to do one extra step, which is that we got to split it up. So notice how this inequality is, there's 2 in 1. It's like a 2-for-1 deal. I have to split it up first. So I'm going to take this portion to the left of that symbol, and then I'm going to take this portion to the right, and I'm going to rewrite them off to the side. So I would write -10 is less than 3x plus 2, and 3x plus 2 is less than or equal to 8. So this is a compound inequality. This is an and inequality because it's a 2 in 1. And then what we're going to do is we're going to solve each of these individually and then put them back together so that we can graph it. So here we go. We're going to get x by itself. And this is where we're going to do something a little bit different than usual.
It's backwards.
It's backwards, right? This x is on the right side, but we're actually going to leave it there. I don't want to move it to the left side. I'm going to keep it right where it is. So instead, I'm going to get rid of everything else. So who should I move over, and how do I move it?
The 2 by subtracting.
By subtracting. Good. So I'm going to subtract 2 on both sides. -10 minus 2 is
12.
-12. And to get x all by itself, I
Divide, which will give us 4 less than 3.
-4.
-4. -4
4. My bad.
less than x. Good. It's backwards, isn't it? That's okay. We're gonna leave it just the way it is. Okay. Now I do the one on the right. Same thing. We're actually gonna do the same 2 steps because what do I have to do first?
Take away the 2.
Take away the 2. Same thing. So subtract 2 on both sides. 8 minus 2 is
6.
6. Dividing by 3 on both sides, I get what?
2.
2. X is less than or equal to 2. All right. I've got these 2 inequalities. I'm going to bring them back together because remember, I kind of tore it apart in the beginning. Now I've got to put those 2 pieces back together.
So,
And the way that we do this is just that x is kind of in the middle. And then I have the positive 2 on the right side and the -4 on the left side. I kind of just pieced it back together. That would be my final inequality, compound inequality. Does this remind you guys of anything?
I
when-
remember we did this before.
When else do we have an inequality where like x is right in the middle like this?
When
When
we're
we're talking about like less, like the least amount and like the greatest amount.
Yeah, we did this on Monday. What is that called?
I forgot what it's called.
Oh, Alyssa put it in the chat. Alyssa got it. Domain and range. Yeah. Anytime you remember when I asked for the domain and the range, you can do it as an inequality where you have the least number and the greatest number and then x is in the middle or y is in the middle. That's where this comes from. That's exactly the same thing. So if this is my inequality, I know that x is in between +2 and -4. And then I just need to watch out for my open circle versus closed circle. So should the circle on the +2 be open or closed?
Closed.
Good. This one's going to be closed. What about the one on the -4?
Open.
That one will be open. And that just depends on the symbol, okay? This one is just less than, so that's an open circle. And this one is less than or equal to, so that's closed. And then since x is in between those two numbers, I'm just going to shade that whole area, everything in between. There it is. That is my inequality. So compound inequalities are we did the same exact thing. It's just like a 2-in-1 problem. You kind of have to do like an extra step because you have to do 2-in-1. But do I have any questions? Okay, so the difference between open and closed. So this symbol is a less than symbol. This symbol is greater than, right? This one is less than or equal to. This one is greater than or equal to. So think about it. Since I have a greater than or equal to, that means that whatever number I'm talking about can be equal to that. Like the equal to part tells me that, for example, here I had the number 2. X can be less than 2, but x can also be equal to 2. So that's why I put a closed circle on my graph, because the closed circle represents the fact that I can be that number. But then the -4 is just less than. X can't actually equal -4. So that's why I have an open circle, because open circle represents that I can't actually be that number. So that's the only difference, open versus closed. Okay, we're going to do one more. This is or now. So that was an and
I need
inequality.
to take a picture of the open circle.
Oh yeah, go ahead. Take a picture. Can I move on?
Done.
All right, cool. All right, so here's another one. This time it's an or. And you know how you can always tell the difference is and inequalities will just be combined like this one was, and we had to like tear it apart. Or inequalities will just say the word or. So you'll always know if it's and or if it's or, because the or will always say or. Okay, so you won't really be too confused. Alrighty. Well, with or inequalities, they're already separated for you. You don't have to split them apart. So then you just go ahead and you solve them individually. So starting with the one on the left. I need to get x all by itself. What should I do?
I'm
Add
gonna
one.
continue making
Add
flashcards.
1. 15 plus 1 gives me
16.
16. So I have 4x is less than 16. And I divide both sides
By 4.
by 4. Good.
Chelsea, are you finding this okay?
All right, and then 16 divided by 4
Are you guys
4.
okay on this?
is 4. So I'm done with that one. And how about this one over here? I'm going to kind of move it over so that we have more room. So 8x greater than or equal to 48. This is just one step. Yeah, all I got to do is divide. Pretty easy. What's 48 divided by 8? What is it?
6.
6. Good. So x is less than 4 or x is greater than or equal to 6. Alrighty. Now let's go ahead and graph this. So there's these are going to be two separate inequalities because this is an or. Remember, with and inequalities, they meet in the middle. But with or inequalities, they're kind of going to go apart from each other. So I have x is less than 4. So what type of circle?
Open.
Open
Open.
circle. Good. And that's going to be pointing to the
Left.
good, to the left. X is less than 4, or X is greater than or equal to 6. Open or closed?
Close.
Closed on the 6, pointing to the
Right.
Right.
to the right.
Is
There
it
you have
like this blue graph that was on the worksheet?
Mhm.
And you also explained it in the video.
Yes. Yeah, we did this on a worksheet, and then I've explained it in the video. Exactly. I'm glad you watched it. You remembered. Okay, so that is that. Any questions? Okay. Alrighty. So the last few minutes, we have about 15 minutes left. We have literal equations. And here's the deal, guys. On the mid-year assessment, I already saw it. The mid-year assessment only has one problem that has literal equations in it. On the other hand, there's about 3 or 4 problems that have word problems in it. So what do you guys want? Would you prefer to do some word problems and practice that? Or do you want to do some literal equations?
Literal.
There's only one problem on it.
Word.
Literal.
You still want to do it?
Word.
And we do
Word.
both.
Yeah, we'll see how much time we have. There's 15 minutes. So what I'm thinking is that we only have time for maybe one literal equation. And then I'll do a few of the word problems. So let's
Literal.
do
Literal.
literal. Okay, let's do literal. Let me see which one I want to do. Let me think about it. Yeah, this one's pretty good. Okay, so literal equations look confusing because it's a bunch of variables. However, we're going to treat them the same as regular equations. We're still following those same rules. So this one is telling me that I need to solve it for x1. So basically it's telling me I need to get x1 alone. Okay, and if I want to get x1 alone, what needs to go away?
The fraction.
The fraction needs to go away, as well as
The x2.
the x2. Yeah, those two things have to leave. They got to go away. So we're still going to follow the same exact steps as a regular equation, which means what do I have to get rid of first? Should I get rid of my fraction or my x2?
Fraction. What I was thinking, we do 2 times x1 plus x2.
Exactly. We're going to get rid of the fraction. And we know that in order to get rid of a fraction, we need to multiply by
2.
By the denominator, by 2.
Denominator.
Yeah, whatever that denominator is. So since I have a 2, I'm just going to multiply by 2 on both sides. Okay. So 2 times m,
2.
2m, yeah. And then since I multiplied by 2, goodbye denominator, it goes away. So now I have x1 plus x2. How do I get x1 all by itself?
By dividing everything by x1. Divide.
If I divide by x1, that's not going to get rid of my x1 because
Add.
yeah, because I'm not using multiplication here. What operation is being used between the x1 and the x2?
Addition.
They're being added together, exactly. So instead of division, yeah, I need to use subtraction. And what am I subtracting? What needs to go away?
The x2.
X2 needs to go away. So I'm going to subtract x2 on both sides.
Miss, how do you do this?
Good question. Can I actually do 2m minus x2?
No.
Yeah, they're not real numbers, so I can't just add them or subtract them. So the only thing I can do is keep them separate. So this would just be 2m minus x2. I'm just keeping them separate. And that's it. Which answer is it?
B.
B, yeah. 2m
Yes.
minus x2. They just kind of wrote it the other way. So notice, this was just 2 steps. All we needed to do were take 2 steps. We still followed all the rules. Remember, those rules are important. You're not going to do whatever the heck you want. You have to follow those steps in order. Okay, we had to get rid of our fraction first, and then we were able to get rid of the x2 using subtraction property. Do I have any questions so far? Okay. I have a feeling you guys probably want to do another one. Is that true?
Word. Yes. Let's do one of each.
Okay, fine. I'll do one more. All right, so here we have 5b plus 12c equals 9, and we need to get b by itself. So I'm highlighting the b just to like keep track of what we need to get alone. All right, there's a couple of things in the way that they have to move over to the other side. So what do you guys think should go away first?
The 12.
Well, the 12c.
Yeah, that 12c is being added to the 5b. So what operation do I use to move it away?
Subtract.
Subtraction.
We can't subtract the 9 with the 12c, so we just separate them, which
You
will
just
be
separate them.
Nine.
negative 12c plus 9.
Good. And you can either do negative 12c plus 9, or you can do 9 minus 12c, because either way it's the same thing.
I remember that you put the variable first.
Yeah, you're completely right. We've actually done it that way before. I'm just doing it this way because when I look at the answer choices, it looks like that's how they do it. So I might as well leave it that way. Okay, well now I have this 5. How do I get rid of that 5?
Division.
Division, yeah. Dividing by 5. And I have to divide by 5 all the way across. So my final answer, yeah, you can't actually divide anything. Nothing divides by 5, so I just leave it the way I have it.
Oh, leave it? Oh, I thought you were going to put it in a fraction.
You could, okay, so you could write this as 9 over 5 minus 12 over 5. But look at your answer choices, Ajira. What do you notice?
There is no fraction with 9 over 5 and negative 12.
Right, so you always kind of want to match your answer to whatever you have as your answer choices. So my answer would be answer choice D. Careful.
Answer choice C.
So answer choice C looks correct at first, but what did they switch around?
Oh, they did the same thing that I did. They put this 12c first, but they didn't add they put negative 9 instead of negative 12.
Yeah, they have them backwards and not in the correct symbol, because if you chose to write them backwards, let me show you what that would look like. Like Ajira said at first, you could also do negative 12 plus negative 12c plus 9, which is different. They wrote 12c minus 9. Okay, so they got that part wrong. So we know that it's D, not C. Okay. So again, literal equations, guys, I get it. They're confusing. They might be tough. There's only one problem on the mid-year assessment with a literal equation. So if you feel completely stressed out about them, like you don't know how to do them at all, it's only one problem. I promise you, if you get one problem wrong and it's that one, I won't be angry, okay? All right, good. We have a little bit of time. Let's do some of these word problems. Let me pick a good one. This one's good. Okay, can I have a volunteer read? John has.
I'll read.
Go ahead, Ajara.
John has the goal to ride his bike at least 100 miles this summer. John has ridden 12 miles thus far. There are 40 days left in the summer.
Perfect. I'm going to write an inequality to represent the average distance, D, in miles John must ride each day for the rest of the summer to achieve his goal. Okay, couple of things. We know that his goal is to ride at least 100 miles.
He has already ridden 12 miles.
He already did 12 miles.
And there's 40 days left.
And then there's 40 days left. Okay.
So can we put it greater than or equal to?
Yeah, so we know whatever he's doing, it has to be at least 100 miles, so it has to be greater than or equal to 100. Okay, so 100 is the minimum amount, so whatever he does has to be greater than 100, greater than or equal to. So good. So I got my symbol, I've got my 100, and I need a variable. Remember that the variable they're telling me to use is D, the average distance that he must ride each day. So let's think about it. Can anyone think of how to complete this inequality?
D will be in the middle, I believe.
So D will be in there somewhere.
12D.
12D. Okay, but 12 is how much he already did. Remember that D is the remaining days.
40D.
So it's, yeah, so it's not the 12 is what already happened. The 40 is what we're going to put next to the D, because the 40 is how many
This
days
is
are
all
left.
Plus
in my
40.
goal for D. That's why.
That's fine. Who just spoke? Was that Bianca? Can you say what you just said again?
12 plus 40D.
12 plus 40D. There we go. That's the inequality, because 12 is how many miles he already did. So this is like the initial amount. 40 is how many days are left. And D is the amount of miles he has to do each day. Miles per day. So we know that D has to be like the slope, because there's that keyword, each day. So, okay, this is kind of telling me the story. John rode 12 miles already. Now he has to bike a certain amount of miles each day for 40 days in order to reach his goal, which is to be at least 100 miles. Do I have any questions on how I put together that inequality? Okay. Well, now part
For
B.
part B, are we gonna have to solve it?
Yeah, that's what I was going to say. Now we got to solve it, because now it says determine the average number of miles that John must ride in order to reach exactly 100 miles. So D is what we got to figure out the value of. And now it's saying if it needs to be exactly 100 miles, what should I change about this inequality?
D needs to be isolated.
D needs to be isolated, and yeah, it's just going to be an equal sign, because I need it to be exactly 100, not less than or greater than, just equal to 100. And now we're going to quickly solve for D. What should I do first?
Negative 12.
Mm-hmm.
12.
What's 100 minus 12?
88.
90 or 88. And 88 divided by 40? 2.2. So here's an example of, do we want this to be a fraction or a decimal if I'm talking about miles?
The
A decimal.
Yeah, definitely a decimal because this is usually when you count miles in the real world, we use decimals, not fractions. So this would be, you said 2.2? 2.2 miles per what?
Miss, I have a question.
Yeah, because
Per day.
Per day. Okay, what's your question?
What is the difference between real word and integers?
If you pass.
Okay, real world is just any problem where it tells a story that happens in the real world. Okay, so like any type of, like, it could be anything. Talking about the car driving or bike riding or making necklaces, it could literally be anything. Integers are numbers that are whole numbers. And the reason that sometimes we talk about integers and the real world is because in the real world, for example, if my problem is something like Stacy is baking muffins for the bake sale. Are those muffins going to be whole numbers or fractions of?
Whole numbers.
They're going to be whole numbers, exactly. So in that problem, the answer has to be an integer, a whole number, because Stacy is going to be baking whole muffins, right? So when you're talking about the real world, you always have to think about, okay, is it going to be an integer or is it going to be all real numbers? In this case, this problem we just did, we're talking about miles, the amount of miles that he biked. So is John going to be biking only whole numbers, or is he going to be biking decimals and fractions as well?
Decimal.
Decimals and fractions as well. So in this case, this would be all real numbers because the answer can be a decimal. It can be a decimal, it can be a fraction, it can be anything that, not just whole numbers. Okay, so that's kind of why I talked about that in the previous class in the real world. All right, we are out of time, guys. Quick reminder, there is homework. So this assignment, a lot of you guys already did it. This one's due tomorrow at midnight. That's for topic 2. But I am also putting up an assignment tonight for topic 1, which is due on Sunday at midnight. So you will have 2 assignments this whole week, one due tomorrow and another one due on Sunday. So please keep track of that. Make sure you complete it. I will post it on Teams again tonight, and I'm going to tag you all in it so that you don't lose it. I'll make sure that you all see it. Okay, so that is all for today. Good job, guys. Great participation. This was an awesome class. I was really happy to hear from everybody. So have a great day, and I will see you guys tomorrow.
Have a nice day, Ms. Lopez. See you
Thank you, Zara.
tomorrow.
See you. Bye.